Alright, what's up guys? So in today's video, we're going to be talking about problem set 9. So let's go ahead and get started. So right now we have this molecule, a benzoic acid. It's being treated with this amine as well as DCC. And in this reaction, all it is this is going to go ahead and replace kind of this group here. That's how I like to think about it. So we're going to have a benzene ring here. It's going to come off like this, and then we're going to form this amide group right here. Alright, this works with amines, primary amines, or secondary amines with DCC or heat, and you do not need to know the mechanism for this one. So in the next reaction, we have this group, we have this alcohol, and we have an acid here, and we have this ring-like structure here with this ester group. So in this case, what I like to think whenever you have a ring in this, basically you could kind of imagine and envision this splitting right here. And when that splits, this alcohol is kind of going to stick on to this side of the ester, and the other bottom side is just going to turn into an alcohol group. So we have this benzene ring here, and this is going to turn into this ester, and this is just going to turn into this alcohol down there, right? So in this next reaction, we have this ester again, we have H2O, and we have NaOH. So in this reaction, what it's going to do is basically it's going to split again, kind of like the previous reaction. But in this case, you don't have an acid, you have a base, so there's not going to be any protonation. So we're going to have something that looks like this, with this minus on the oxygen, and this sodium is going to be next to it. And this is also going to form this group right here, right? In the next reaction, we have this amide here, cyclic amide, and we have this water, HCl, and heat. And again, kind of similar concepts. This is kind of going to split apart. And once this splits apart, it's going to turn into a straight chain. So when it splits apart, you're going to have something that looks like this. Remember to count your carbons. That's a really easy way to make a silly mistake when we don't want to. So we have 4 carbons. This is going to turn into a carboxylic acid like that. This is just going to pop off and turn into an amine. All right. And the next step, next reaction here, this is a named reaction. This is the Gabriel synthesis reaction, and in this case, you also don't need to know the mechanism. And this is how we make primary amines. So we have this halogen group here attached to this ethyl group here. Basically, that's going to form this. And this is kind of going to split up, forming 2 carboxylic acids. And the important thing we want to know here is that this forms this primary amine, NH2. That's like the key thing from Gabriel synthesis, forming primary amines. So next question says, the following reaction would not occur. So it's telling you the outcome, and it's asking you to explain the rationale. So this can be justified because this is an acidic group, and this is a base. And this would just form an acid-base reaction instead of kind of this replacement of this alcohol group right here. So we can say would be acid-base reaction, not substitution. All right. Now we have question 3. This is a acid catalyzed hydrolysis of a nitrile. This is a nitrile group right here, and we're asking to acid catalyze it. So good thing with these guided synthesis things is if you remember your formulas and your equations, then you can kind of have a general idea of where we're going to be going. Right? So since we know this is acid catalyzed, we're going to end up with a carboxylic acid of some sort. So let's draw out the arrows. First step, we have this lone pair on the nitrogen going to attack this hydronium, and this double bond is going to go back onto the oxygen, and this is going to form this group right here. Nitrogen with a hydrogen. This has a positive charge. All right. So the next thing, we have to figure out how to get from this molecule to this molecule. So in order to do so, we have water floating around in solution, Remember the previous hydronium ion, or not ion? Yep. So we have this water group here, and in this case, one of these lone pairs is going to go ahead and stick right here on this carbon, and one of these double or triple bonded electrons is going to go into the positively charged nitrogen, forming this group here. Next step, we're going from this molecule to this molecule. We can kind of see any convenient base. Go ahead and stick there. You can kind of reason that out. Not the most difficult step. And we have this molecule. Same thing with the next step. We can kind of see, since it's guided, what is kind of going on. This lone pair is going to attack this hydrogen. Going to collapse onto the any convenient base, forming this. And then we have a resonance structure. This is a resonance arrow, not an equilibrium arrow. Please don't get it confused. So resonance can occur like this, forming something like this. NH2. All right. Draw the lone pairs here. This step here, we have any convenient base. We see the next product here. We see that the any convenient base is going to take this hydrogen. It's going to go back onto the oxygen. I drew too many lone pairs. And we're going to get this structure. And finally, the final product here is going to be this. And this is just one of the reactions that you guys are going to have to memorize. All right? So thank you so much for watching this episode.